for his excellence, including receiving a Molecular Clarity Award in 2018. We are indeed very fortunate to have him with us today. So without any further ado, please join me in giving a warm welcome to Professor Kenji Monde. So all the floor is yours, Sensei.
Thank you, Adam. Very kind introduction. So I didn't expect my student to introduce me in the Malaysia. As I told you, she was the very good graduate student. She got a PhD in our group in Hokkaido, and she speaks Japanese very well. Whatever, and thank you very much for your give me the opportunity to talk about our recent and the progress about the organic chemistry and as well as biology. So today I'm going to talk about some sphingomyelin cysteine inhibitor to the natural antiviral against to SAR COVID-19 treatment. Shall we shut down so that the people watching can switch on the light? Yeah, right. Okay. Here is I came from the Sapporo, and here is our university, and you can see, and this is the middle of the Sapporo city, and 2 million people is living here. It's the same and population as Kuala Lumpur, but and just our university located in the center of the city, just 5 minutes walk. And the pop quiz, where is Japan? Where is Japan? So A, B, C, D, E. Do you know where is Japan? Oh, great! So I didn't see, I don't expect it for the people know about that. Okay, A is correct. Do you know where is the Hokkaido? Nobody know about this one, right? Okay, Hokkaido University, where is it? Okay. Here is the Earth, okay? And as is getting closer, as A is Japan. And here you can see Northern Island. It's located north. It's Hokkaido. And here is Hokkaido, and here is Sapporo. Sapporo is the capital of the Hokkaido. And here you can see the largest campus. And here is just the central station of the Sapporo, just 5 minutes walk. And we have 150 history, and that is the oldest university in Japan. So because of our university is established in 1876. 1876 is just after Edo Age. And Edo Age, we have many samurai. We don't have any culture. We don't have any industry. And just after the 9 years, the new government make it our university. So that is so. And after that, because of Hokkaido is the empty area at that time, so not so many people is living in this country. So the Japanese government, new government is make it the people to send it to Hokkaido and make it a new land. So So same time, so they make it a university. That's why it's the oldest university in Japan. So the Professor William S. Clark is the at that time. So we don't have any culture and university. So you can imagine we and the government invited the professor from the United States. He came from Massachusetts Agricultural University, and he gave us the lecture about agriculture. He just spent 10 months, but he gave me the very nice frontier spirit to the Japanese students and the Japanese people. And here, as I told you, the Sapporo is the number 5th city, and first one, biggest one is you can imagine the Tokyo. You know about Tokyo. Tokyo is almost 10 million people is living. And the next one is the Yokohama. The third one is the Osaka. Fourth one is another. Fifth one is the Sapporo, and population is 2 million. And so far, it's the same as I think the current, and it's a big city. So when we made it the university, do you guess how many people, how many Japanese people living in Sapporo? Right now it's 2 million, but 150 years ago the population was, you can guess how many?
Yes.
1 million. Okay. 1 million. 1.5. What? 1.5. Okay. Okay, you can guess. And after 150 years ago, Sapporo population was 7. No Japanese was living around here. So during the 150, so it's expanded up to the 2 million. So that's why the history of the Sapporo city is exactly same as the history of our university. So that's why our university is located at the center of the university. Okay. And sometimes high temperature is 36, but usually up to the 30 is the maximum. And right now it's almost 20. And also you can imagine the winter time. You can imagine, and here is very humid. Tokyo is humid, but Sapporo is not humid. Very comfortable with whatever. If you go outside in summer, spring, very comfortable. So that's the meaning. So many people tourists coming to Sapporo. Oh, but the winter time, so you can guess minus 10 degrees sometimes. But inside the house is very warm, and it's specially made by heat protection. So here is my car in the winter, so it's all covered with snow. So sometimes this is my airport. I parked for my car. Sometimes I can't find where is my car. So. Okay, as I told you, the largest university in Japan. So Sapporo Station is here, and here is the main campus. We have a botanical garden, dormitory is here. And also, not only the campus, but also we have experimental forest. Because of a huge area, we have experimental forest. Total area is 0.2% of the Japanese whole area. And we have 12 undergraduate and 21 graduate school and 26 research and institute center. And staff, academic staff is approximately 2,000, and technical and administration the 2,000, total 4,000 staff. And the students, undergraduate 1,100 and 11,000, and also graduate school the 6,000, and totally 20,000 and the students is up there. And budget is approximately 100 million Japanese yen. Okay, and the summertime is very nice and green and outside, 20 degree, and not really. People enjoy in the outside and barbecue in the summer. And also, and we are good at chemistry. As I told you, we are working for the chemical biology, the chemistry and biology. And some of you might know the Suzuki coupling. Suzuki coupling is the couple with the make it the biphenyl group and using the borate and palladium catalysis. And he created, Professor Akira Suzuki created. He got a Nobel Prize that he grew up in our university. He got a Nobel Prize 2010. We got made also the Benjamin List. He is working for the right now is the German Max Planck Institute. At the same time, he spent the time to our university for appointment professor. So after that, so we started for the collaboration with Benjamin List. He got a Nobel Prize. So that's why we got the Nobel Prize, the winner in our university. Okay, again, so here's our university. Our laboratory is located here, upper side. Because the two huge things here, and the southern part is developed earlier, and northern part is recently is developed. So we are making special breeding for the cutting edge technology, also the making for the collaboration with the industry. And here the small building is made by a private Japanese pharmaceutical company. This is the first case to the collaboration with the pharmaceutical company and with the university making for the some original research building. So this is the organic chemistry, the laboratory, and so they are, you can see the rotary evaporator is the same as the here. And this is my desk. My desk is always covered with a lot of paper. And what I'm thinking about, maybe I mean, already introduced to you. Right now, it's working for the cabinet office, the Japanese government, and provide advice for the science and technology approach. Major field that chemical biology. Okay, I'm gonna talk about. I'm thinking about. I'm going to talk about three topics. One is the anti-obesity and science topics. The anti-obesity is a very serious problem, and because of and once you get enough money to, it's always thinking about obesity. Here in Japan also there's so many fat people there. So, but if you go to the United States and so many people fat, maybe they maybe 80% of the people is getting fat. So serious problem about this one. So what we are doing about is lipid chemistry. So we are doing about special lipids called the spigolipid. So every organism, including the human, has this lipid. And it's first isolated, described isolated for the chemical construction of the brain, 1884. Because of enigmatic future, because they have some two part is organic and water soluble part and water insoluble part. So that's called it's similar to the Sphinx. Sphinx is made by the lion and the human. It's two different characters. So that's why it's named the Sphinx lipid, sphingolipid. The structure, as I expected for the people who know about chemical structure. Structure is for the organic chemistry. It's easy to understand. They have two asymmetric center, two OH group, and one amino acid group. with longer hydrophobic longer chain. So typical one is here. If they attach here, H is the ceramide. Ceramide is the famous for the component of the skin. If you go to the perfume company, so it's always thinking about ceramide. And phosphate case is a specific signal, and also the choline case. This choline case is the two charge. They have a minus charge and plus charge. We name it sphingomyelin. This is very important sort of component for the membrane, and I think it's related for transfer of some signal. Okay, and one of the focusing enzyme in the sphingomyelin synthase, we name it SMS. Sphingomyelin is, as I told you, the structure is like this one. It's come from the ceramide. Ceramide is the OH in the T. At the same time, this PC is transferred to the choline part. That's the one role of this enzyme. And from the ceramide, the sphingomyelin, they made it. And located is the two things. The location is the cell surface. The name is the SM1, 2. And the other one is the Golgi apparatus. In case of the Golgi apparatus, the name is the SMS1. But both the isozyme, the same shows the same function. Both show the same function. But once we kick off the knockout means kill, knockout or knockdown case, and this is a serious problem. Maybe in case sometimes the cell will self-die. So it's the SMS1 is essential. Why SMS in case of the SMS2? So when we kill or knock out and knock down, so we don't have any remarkable phenotypes. So if you want to make it some drug discovery, so first was we have to make some target protein. That is the most important work to find the target protein. It must be the work for toward for the disease, and also it must not work for the life maintenance. So we're going to collaborate and find out if you knock out the SMS2, so decreasing the weight drastically. Also, same time, so it's effective for the Alzheimer's disease. So Alzheimer's disease is like recently a serious program in Japan, and as well as the Western country, because of so many people is live for a long life. So at the same time, they have some problem about the brain. So because of so many number of the Alzheimer's disease patient is increasing. So we are thinking about this must be the good target. And before that, so we didn't find anything the good inhibitor of the SMS2. We're gonna apply for the natural product chemistry. And the natural product chemistry is the finding the active compound and secondary metabolite from usually plant. Especially I think I started for the chemistry as a natural product. So I'm very familiar with the natural products. Also the researcher in the here is very familiar with the natural product chemistry. So we're going to make it some assay method to using for the genetic engineering technique. We produce the large amount of SMS2. And as usually we have checked about functionalization, extract and functionalization to use to find out compound. And finally, we have now from the 500 cubic slot and 5 active plant contact and 12 natural inhibitor response. So one of the compound which I'm very interested in is which comes from Malaysia, and this is the nutmeg component of the nutmeg, and it's a kind of the fruits in the which make and eat in the Indonesia and the India, and as well as Malaysia. The compound is named in Malabaricum. Structure is not so difficult. It's very simple, like this one and this one, this one, this one. And they inhibit the SNS2 very gradually. And actually, its concentration is 4 and 6 micromole. And also, we can find that tested for the tissue of the mouse, and it works toxicity. So it works very well. And finally, we can use the mouse weight control. Here you can see, and this the middle mouse is they feed for the high fat diet. High fat diet is including very high fat and calorie. So if you eat it, so we not very fat. But instead of this one, so normal one is quite normal. But if you add it for the Malabaricum C, it's decreasing the weight like this one. Okay, and the first one is the we can get some the compound from the Malaysian plant, and that's so the important for the inhibition of the SNS. And practically it's applied for the weight for the reducing of the weight for the mouse. Okay. And here is the second part is the COVID-19. So as I told you, people, all the people know about COVID-19 is still a problem about our world. Yeah, sometimes increasing the number of the COVID-19 patients. So COVID-19 is come from the SARS-CoV-2. So it might be the virus, and the virus come from the important protein. The S protein is the S protein is the have a H2 product, and here, because of we are working for the SNS2 inhibitor. So during the COVID-19 period, we have found some report, and it's because of we have working for the SNS2 inhibitor, nucleic acid, galactonic acid, Malabaricum C, and one of the nucleic acid showed about one paper showed that nucleic acid isolated from ginkgo biloba inhibit the fusion of the umbilical waves. Because COVID-19 also the umbilical waves. So that's why we have tried to the inhibition assay of the during COVID-19 of our inhibitor against the SNS2. So MTT assay is not so difficult. MTT assay is easy and people what's used. There's a compound here and the very easy E6D cell is inside. And after that, SARS-CoV-2 is infected, and after that, 72 hours later, so put the MTT and change it to the counter. So that's easy. But because of our colleague in and he's doing research at our next building. So he's a professor. They are professional about COVID-19, including for the SARS-2. So also they have some special equipment using for the so-called biosafety level 4 and 3. So that's the why we are doing about this project. Then first we have tried to the metabolic C and other SNX inhibitor from the natural world. So one of the compound which I showed and metabolic C isolated from the nutmeg, and it shows very good activity about this one. So we're going to try to make it the SAR study. SAR is the structure and activity relationship study. Okay, chemical system. I don't want to tell the detail about, but chemistry is usually use this organic synthesis methodology. Okay, and we made it some compound. It's the real assay method. If you highly concentrate the purple one, it's mean the cell infected for SARS-CoV-2 is alive, while the white one is the dead. So we have to find out the survival one. Okay, here is the SAR study. I don't want to talk the detail, but we are made many kind of the compound which found what kind of compound is very effective. Okay, the another one is how this compound avoid for the infection. So because of you can see this is the control compound, controls the cell after the infection. So you can see in the big cell. Because of if you infect the COVID-19, COVID-2, so cell to cell is the merge, it's make it better. So as a result, the cell is a death. Once cell is a death, people is going to die. So here is a movie is how to. So cell is going out after the infection, and cell is we call the merge. It's called the fusion. If the cell will fuse, the cell is the death. So to clear about this the fusion assay, we make it utilize the product color. What we did is we make a two color of the same cell. One is the green, the other one is the red. Red was the we introduced the cherry pigment, so genetically, and the white green was famous one. GFD was incorporated this one. So this the typical cell was the colorized the typical pigment protein. So once it's the fused, red and green is make a yellow. So once we can count it, the number of the yellow, it is utilize the whole formula. Here is the left one is the we didn't put any inhibitor. The right one is we put the inhibitor. Okay, you can see the left one is the going green one, and red one is going to merge and make it the yellow. Okay, so this one is a cell. The right one is once infected, the same one, but we added the compound 6. So this one still slightly yellow, but still continue red one and green one. So this means this compound, so avoid to the fusion. Okay, and white and SARS-CoV-2 only effective, so that they show yellow one, the control one here. But once we put the other compound, so the yellow part is decreasing. So we concluded that the Marbaricol C is the against for the fusion. Okay, the third one is the photoaffinity leveling. Photoaffinity leveling is the technique. So because we want to know the 3D structure of the protein. The one typical one is the X-ray, and the other one is the NMR spectroscopy. Recently we used the cryoprobe microscopy, also the powerful method. The three methods is the measure. But for the chemically, the other method is the photoaffinity leveling. Photoaffinity leveling is we can put some ligand and the target protein and the photoactive part, and we can put another tag is here. Tag is sometimes fluorescence or how to extract biotin to extract for the selectivity. So here, firstly, ligand is attached to the target protein and the photoactive part. Photoactive part is like this one, N2 or N2, and this benzophenotype or this one. This one is once irradiated photo by UV irradiation, it makes the covalent bond here. And after that, so we can find out what is the ligand part is the target protein find. So typical one is that one. So the IME and Murai Sensei is created for the no-zero photoaffinity. So no-zero is this nitrogen here, and sulfone is here. Because of nitrogen is affected, this is SH is chemoselectively attacked here, and leaving for this part, and we can remove this one. Why they use for this part? Because of if we use for this chemistry and easily to introduce any tag. Tag should be the fluorescence, tag should be the biotin, anything we can introduce. So she and IME and the licensee is try to synthesize this molecule. About fluorescence, they use this kind of body beam. This is the famous green fluorescence, and this is also the other fluorescence tag. We have succeeded for the introducing of fluorescence, and they make it new type of the agility. Okay, this is the final one. Final one is we have tried to the BSA. BSA is not for the target, but easy for the testing, for the binding, after the binding for the photoaffinity probe, we succeeded to introduce for the fluorescence probe. So far, that is the conclusion. Okay, finally, and I'm going to explain about our IGP program. IGP program is a graduate student and graduate student for the graduate student scholarship program for the Japanese government. So this is an international student and exchange from all over the world. Education in English and master course and doctor course is available. Okay, IGP is supported by the Minister of the Education and the Cultures, and the next is the Japanese government fully supported for the scholarship to travel to Japan, and also the tuition and the living expense. And this time, so we're gonna explain about 2026 next year, October. This year is already finished for the next year. 2026 October is started. Okay, we're gonna we're gonna explain about there is a two types. 3 years of scholarship for the PhD and 2 years scholarship for the master course. And in case of the PhD course, this case next year we expecting for the 5 PhD course. And while the master course is the 3 master course students could be expected. Okay, and if you have to application the process, if you are very interested about our program and also our research against not only the me, but also the toward for the member in the belong to the faculty of the advanced life science. And you can see some you can contact to some professor directly, which belong to the faculty of the advanced life science. Until 2025, this year, the end of October. After that, so we're gonna start it for it. Before that, the professor always use the screening. So if you are very find out some of the interesting professor, you can ask for the directly to the professor in the Hokkaido University. After that, so we will start. Okay. Anyway, and so far we have I think three Malaysian students. Our group member has a good Malaysian student, and one of the Aini come from Malaysia, and the other Akmal also come from, and she come from the Indonesia. Our assistant professor is Animal Sensei, and Tanju Sensei is the associate professor. She is especially working for the hierarchy in chemistry. And Sato Sensei is he come from the pharmaceutical company, but he likes the virus very well, and he already made it to practical drug in the pharmaceutical company. And this is the rare case. He is right to the promotion, but he likes the research. He moved to the university instead of the promotion of the pharmaceutical company, and he screened every compound against COVID-19. He found some COVID-19 antivirus drug in this time. So anyway, and here is final one, and he is our group member. Sometimes we go outside and drink and eat lunch. There is several there is several international. He come from the Nigeria. They come from India. So maybe the Turkish postdoc and also Nigeria, Indonesia PhD student join this autumn. Okay, we are going to the international research and we are going to the international field. If you're interested, please keep in touch. Thank you very much for your kind attention. So if you have some questions.
Thank you very much, Daisy, for the sharing sessions. I think it's very nice to see some research work, some applications, especially on the organic synthesis part. I think some of them actually left for classes. So I would like to open up the floor for any questions.